Now let's take a look at the product and quotient rules, and also when we have higher order derivatives like second derivatives or third derivatives, etc. So for this section, I've put the product and quotient rules together. I gave trig its own video, and then of course higher order derivatives. Let's start with the product rule. And again, these are just rules that you're going to want to memorize. You're going to use them so much it won't even be memorization. It'll just be a process that you remember. But essentially what we're saying is if you're finding the derivative of a product, so we have two differentiable functions that are being multiplied together. To find the derivative of that, I'm going to take the first function times the derivative of the second, plus the second function, g of x, times the derivative of the first. And that's always the way I say it, so you're going to get really sick of hearing me say it, but let's take a look at some examples. So let's use the product rule to find the derivative of h of x. The derivative of h of x would be finding, using the product rule, these two products. So again, I'm going to use some different colors here. Before we use the product rule, I just want to show you what the derivative would be if I chose to use not the product rule, to multiply this out and then just take the derivative of each term. So if I FOILed this out, I would get 15x plus 12x squared minus 10x squared minus 8x cubed, which would simplify to negative 8x cubed plus 2x squared plus 15x. And then if I found the derivative of that function using, again, the power rule, negative 24x squared plus 4x plus 15. So this is where I should get to when I get to the end of this. So let's take a look if I actually do get there. First thing I would do, of course, I just have my normal functions. I'm going to find the first times the derivative of the second plus the second times the derivative of the first. Now, when I'm actually doing this, I tend to not show this step. So I'm showing this for your benefit so you understand where everything's coming from. And the more you do this, the easier it will be, and so you'll skip this step as well. But don't feel bad if you have to include this step for now. Again, I'm taking the first here times the derivative of the second, and then the second times the derivative of the first. Then I'm going to essentially keep the ones that I've underlined in the straight lines exactly as they are and use this step to go ahead and find the derivative. So here is where I would typically go straight to this step. So the derivative of 5 plus 4x, this derivative is 0, derivative of 4x is 4, so that's where the 4 came from. For the one I have underlined in purple, the derivative of 3x is 3. The derivative of minus 2x squared is minus 4x. And from here, it's really straightforward because it's just algebra. I'm going to either distribute or FOIL, whichever is appropriate, and then I'm going to combine like terms. And notice that I came up with the exact same value that I did when I did it the other way. So you might be asking, why would I ever use the product rule? You might want to, because even though this one, it seems like less work to do it the original way, the product rule is going to come in handy so often, especially as we get into more and more complicated problems. So let's take a look at another one. Notice here I have a product and I also have a sum. That shouldn't throw you off too much because this guy is just going to kind of be treated separately. I'm going to find its own derivative. This is where I'll be using the product rule. Keep in mind that, of course, I'm going to write the square root of x as x to the 1/2. You always want to do that before you get started. So here's my original function, and now I'm going to use the product rule to take first times the derivative of the second plus second times the derivative of the first, and then, of course, don't forget about our x cubed guy. Find the derivative of that as well. So again, my next step, I'm just going to find my derivatives, which is 2x minus 3, and then 1/2 x to the negative 1/2. And then again from here, it's just multiplying, combining like terms, etc. Get real comfortable with fractions because you're going to use them all the time. So remember, If I take x to the 1/2, I have to take 1 plus 1/2, which is 3/2. Please don't ever write x to the 1.5 or 1.5. Always keep them as a fraction. So again, I'm going to continue to just distribute, and then I'm going to combine like terms. So I've got 2 terms that are x to the 3/2, 2 terms that are x to the 1/2. I'm just going to combine those together. Again, you got to get comfortable with fractions. So here is my final solution. Here's another one for us to try, and this one, it's interesting. I could do it in a couple of different ways. So I can either think of this as 3 as a constant, and then product rule with x squared and sine of x. Or I can take 3x squared as one of my 2 factors and then sine of x. So I'm going to solve it this way, but if you want to, just for fun, solve it using this way, you should get the same answer as me when we get to the end. So again, finding the solution using the product rule, here's my 2 products. So I'm taking the first times the derivative of sine, which is cosine of x, and then I'm taking the second, sine x, times the derivative of the first, derivative of 3x squared, is 6x. So again, now I'm just combining what I can, and really I could stop here, because 3x squared cosine x plus 6x sine x, and again, this is the proper way to write it with the constants and variables in the front and trig function at the end. Also, I could factor out a 3x, so I would take either one of those as a correct solution. So now let's take a look at the quotient rule. Again, you're going to use this one and the product rule all the time. And the quotient rule says, take the bottom, and again, this is just the way I say it to help myself remember. So yes, it's the denominator, but I always say bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. So that's the way that I say it in my head so that I remember the pattern. Bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. So let's take a look at our first example. If I wanted to find h prime of x, remember my pattern says take the bottom times the derivative of the top minus the top times the derivative of the bottom. And all of that over the bottom squared. I could, as I've told you before, go straight to this step, and straight to this step is again just less writing, which is fantastic, which is go ahead and find what is the derivative of 5x minus 2. It's 5. What is the derivative of x squared plus 1? It's 2x. So that's typically my next step. I typically don't write this step up here. So now again, it's just algebra. From here, I'm going to distribute the 5. I'm going to distribute the 2x. And I could have distributed the minus and the 2x, so I could have had just right away 5x squared plus 5 minus 10x squared plus 4x over x squared plus 1 quantity squared. Resist the temptation to multiply this out. Most of the time we don't want to multiply things out in the denominator because we want to see if anything will cancel with it in the numerator. From here, again, I would just combine the 5x squared and the negative 10x squared. This would be my final solution. Before I'm ever done, I would always look at my numerator and say, is there anything that I can factor here that could possibly factor or cancel with a factor in the denominator? And I know for a fact that I wouldn't be able to factor out an x squared plus 1. Hopefully you can see that too, because this is an x squared, so obviously I'm not going to have another binomial factor that includes a variable. So I'm not going to continue with this one. This is my final solution. I wanted to give you one of the trickier ones that might help. You're going to come into contact with these a lot, And again, it's just something that you're going to use so much that at the end it's going to be super easy, but right now it's maybe not so easy. So if I want to find the derivative of this, notice it's kind of complicated because I've got quotient rule, two things being divided, I've got things being added and subtracted, and I have a fraction. So sometimes it's easier, and when I say sometimes I mean all the time, it's so much easier if I just take everything times x. So look what's going to happen. I'm going to take 3 times x to get 3x. I'm going to take 1 over x times x to get 1. I'm going to take x times x to get x squared. I'm going to take 5 times x to get 5x. Now, is it cheating to do that? No, because what I've essentially done is I've taken this equation times x over x, and what does x over x reduce to? 1. So I've essentially taken the equation times 1, but what it has done for me is fantastic because now I don't have any crazy, x to the 1/2 that I have to take, here and then over here I have to take the derivative of it, etc. So take my word for it, so much easier to multiply it by x first. And now I can use the quotient rule, which is pretty straightforward. Bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. And again, from there it's just algebra. So I've distributed, I'm combining like terms, and then it says find it when x equals 1. So here's my derivative. If they said find the derivative, I'm all done. Then they said find the slope of the tangent line when x equals 1. X equals -1. So I'm going to plug in -1 and solve, and the slope of the tangent line is 0.